Welcome to your first classical experiment problem video. When approaching these problems, you'll need to have a good understanding of the three experiments: Rutherford, Thomson-Aston, and Millikan. So be sure to review the lecture and the lecture notes for further explanations about those experiments. Many problems about the classical experiments will involve proportionality, and this is an example of one of those problems. You'll want to approach classical experiment problems in the same way that you approach any other proportionality problem. If you would like a refresher on how to do proportionality problems, please see the Lecture 1 videos. The first step in any proportionality problem is to identify the two things that you are comparing. So reading the problem, we see that we have the gluon and the electron. Next, you'll want to identify any variables that they give you information about in the problem. So we see we have momentum and mass, velocity, magnetic field, deflection, and charge. Great, so now that we mark those down, we'll want to think about the variables we have and identify any equations or expressions we know using those variables. So in the problem, they tell us that momentum equals mass times velocity. So then we can write the expression momentum is proportional to mass times velocity. Then, looking at the lecture notes, you'll see that we discussed the expression deflection is proportional to charge times velocity times magnetic field times 1 over mass. And since we have 1 over mass, we'll also want to write a semicolon and then just mass next to it to make the calculations more clear for us. Now that we have the expressions using all the variables we identified, we can move on. So we'll want to draw our proportionality boxes and write in our equal signs first. Then after we have that down, we'll want to label all of the boxes. So recalling from the first proportionality videos, you'll want to put the particle we want to find information about in the second box, and the particle we have more information about in the first box. So since we want to find out about the gluon, we'll put the electron in the first box, and then the gluon in the second box. And then the last box will always be the factor line. And you'll want to do that for both proportionality tables. Awesome. Now we'll start putting in information from the problem into the proportionality table. We see that it says that the momentum for the gluons is 40% greater than the momentum for the electrons. This is a bit tricky to understand, so let's break it down. If the momentum of the electron was 10, you could add 40% of 10 to get the gluon momentum. So since 40% of 10 is 4, in that case, the momentum of the gluon would be 14, 10 plus 4. Another way to think about this is that the gluon is 1.4 times the momentum of the electron. So that means that we can write the factor as 14 over 10. Using similar logic for the velocity, 40% less than the electron is the same as saying 60% of the electron. So the factor would be 6 over 10. If it's hard to see how we got there, try using an example with a number and see if that helps you come to the same answer. Okay, so using this information, we can solve for the mass factor in the first table. Using the other two factors, we calculate that the mass factor is 7 over 3. And then since we're talking about the same mass factor in the other proportionality table too, we can transfer this factor to that table. And then after you have that written down, to get 1 over mass, you take the reciprocal, which would be just 3 over 7. So since we know that in the problem, both the electron and the gluons are passing through the same magnetic field, the factor for the magnetic field is going to be 1, because they're the same for the gluon and the electron. Next, we see that the problem tells us that the deflection of the gluon is 5/3 times of the electron beam, which makes the deflection factor 5 over 3. Finally, we can also transfer the factor we got for velocity in the first table into the second table, 6 over 10. Now that we have the information in the problem about the factors, let's see what information they give us about any values we can use in the top box. So we see that they give us the mass of the electron, so we can write that one in. And then they also give us the charge too, so then we can write that in above the charge variable in the table. And then we see that the problem is asking us to find the charge and the mass of the Zuon. So let's just circle where on the table we would find those values. And then next, from our first proportionality videos, we went over that the top box times the factor line equals the second box. So we're still missing the factor for charge, so we're going to need to find that first to calculate that second box value for charge. So since we have all of the factors in that second proportionality table except for the charge factor, we can calculate the charge factor. So after doing that algebra, we get that the factor is approximately 6.48. Now, so going back to mass, taking the top times the factor for the mass, we get that the Zuon mass is approximately 2.13 times 10 to the negative 27 grams. And we get that the Zuon charge is approximately 1.04 times 10 to the negative 18 coulombs. These two numbers is all that the problem is asking for, so you are done after this step. I hope this video helped.